Hello everyone and welcome back to Engineer Tomorrow's Thermodynamic video series. This is video number 11 and today we'll be discussing the thermodynamic water tables and how they can be used in your thermodynamic analysis. So first of all, I wanted to go through what each of the components is on this table and just kind of describe one new one and identify another one which we will be using later on. So first of all, this is the temperature in degrees Celsius. Okay. This is, first of all, this is the properties of saturated water. So at a temperature of 50 degrees, it provides you with your saturated water pressure. Okay. And additionally, it gives you the specific volume of the saturated liquid and the specific volume of the saturated gas. So if you remember the water dome, which looks something like this, okay, so let's say this is specific volume versus your temperature. Okay, you know that as you transition from this location to this location, evaporating, so from the liquid to the vapor, your specific volume will change, and you can see that here. You have your vapor saturated specific volume and your liquid saturated specific volume. Okay, and this, if you remember the constant pressure line, you know that the pressure remains constant in that water dome, and that pressure is provided right here based on your given temperature, and there's a lot more temperatures that are on this table as well. So here in this section right here, you get the internal energy. Okay, and that internal energy we often refer to as U. Okay, and this is a per mass basis. So per mass. Okay, so if you have a certain amount of mass in your system, you multiply it by your internal energy and you get the total amount of internal energy that you have in your system. And again, they are different for the saturated liquid, which is on this side of the dome, and saturated vapor, which is on this side of the dome. Next, what we have, or before I go on, as you can see, the saturated liquid internal energy is going to be less than your saturated vapor internal energy. And that's to be expected because you need to add energy to your system so that you can evaporate. And as you add the heat, you go through this evaporation process and your internal energy increases. Okay, and next we have this concept of enthalpy. Okay, so enthalpy is often referred to as H, or on a per mass basis, lowercase h. Okay, and H is equal to the internal energy plus the multiplication of the pressure times the specific volume. Okay, and the reason that this is used is because oftentimes when you do open system analysis, you get this pressure times specific volume term that drops out, and this just allows for a simplification of this in your equations. So it's important to note that enthalpy is often used for open system analysis, and internal energy is often used for closed system analysis. Okay, so I just wanted to introduce this concept. This part right here is often referred to as flow work. Okay, so there's a certain amount of work that's being done based on your temperature and your pressures and things like that. So just wanted to introduce this concept before we continue with our discussion of the water tables. So here you have the saturated liquid enthalpy value, and you have your evap H sub Fg. Okay, and I want to describe what that is really fast. So that's your enthalpy of vaporization. Okay, and what that does is it actually tells you how much enthalpy you need to add to your system if you want to fully evaporate a saturated liquid to a saturated vapor. Okay, so if you look at this dome, okay, and you remember that up here is the critical point, but let's get pretty close to the critical point. Okay, so let's say the temperature starts getting higher. You should see that the difference between this and this actually decreases. Okay, so this increases by 20, and this only increases by 10. Okay, so the difference between them, you're going to notice that the difference at higher temperatures is going to be less than the difference at the lower temperatures. And that's evident in the table, specifically if you go to the higher temperatures as well. Okay, and then last but not least, you have this term of entropy, which is going to take me a lot longer than one video to explain, so I will leave this for future videos, especially in our discussion of the second law of thermodynamics. Okay, so once again, this is just the properties of saturated water. Okay, so this is only for water. There's different pure substances, like a lot of refrigerants, they have these tables as well, because they're used in HVAC systems and things like that. So if you're doing a water analysis, you can use these, but it can't be used for anything else. And then next we have the properties of superheated vapor. So if we look at that on the temperature versus specific volume plot, we have this section over here. Okay, and that's the superheated section. You're beyond the saturated vapor line. Okay, and what you get is you have a plot of a certain pressure. So if you know your pressure of your system and you know your temperature, you can see that there's a relationship between them. And you may say, okay, well, what if I have a temperature of 100 degrees Celsius? What do I do? Well, there's interpolation that you can use, okay, which we will discuss in the next video, along with the concept of quality. And you can use this to determine, the in-between value for a specific pressure. And there's other pressures as well. This is just one that I happen to show on this video. Okay, and once again, you get the temperature, specific volume, internal energy, enthalpy, and the entropy, which we were not discussing in this video. Okay, so I hope that kind of clears up some things. Yeah, so if you have any questions, please let me know, and I look forward to seeing you guys in the next video. See ya.